Okay, whoa. Don't copy it. Don't copy it. This is a lot to copy, all these limit laws. There are 10 of them. I'm going to give you, digitally, I'm going to give you a digital copy of, let's see, all this here. So I'll give you a digital copy. And by request, I can provide a physical copy. So think about that before you copy all this down. But you can copy it down if you want. Okay, so limit laws. So kind of rules we're allowed to apply to make our life easier when calculating limits. A lot of these things are intuitive. Now, when we say that the limit exists, maybe I can translate that. That's the same thing as saying lim equals some real number. I like this version better, but anyways. So we're going to insist in laws 1 through 10 that the two limits here exist. They're both real numbers. Okay, now we're saying that if you have a sum, then you can move the limit across. That's pretty straightforward. You can move the limit across a difference. If there's a constant, it can be moved out front. If there's a product, then you can do the limits separately. Again, provided both these limits exist. Okay, all of this falls apart completely if one of the limits doesn't exist. Like not existing, meaning like it could be infinity or minus infinity, or it could be even worse, just some kind of oscillating thing that doesn't approach anything. Okay, quotients. And you can put these limits into English if you like to help you digest them. There are some more limits. More laws, rather, 6 through 10. Okay, this one tells us how to deal with powers. So if you have like limit x goes to 2 of x cubed plus 1 to the 4. Okay, what you're allowed to do is just move that limit inside. That's what number 6 is saying. And when I use number 6, when I use law number 6, maybe you want to just put a little 6 here. You don't have to, but they may help you organize your thinking. 7 and 8 are, we're getting very precise here, and we're making very precise things that may seem obvious. Okay, a limit of a constant is just that constant. Limit of x is going to be, well, just a. Nine, again, we have powers. And then number 10, we have square roots. Now, if n is even, there is a little detail here that's important, because you can't do the square root of a negative number. I mean, there is no real number that equals this. So that's the reason for this extra bit of English down here. Now, these limit laws, you have this x goes to a, x goes to a, x goes to a. These work if you have one-sided limits as well. So let me say that as these work if a is, a plus, let's say a is replaced by, one-sided limit of that form or the other form. And we'll see later we'll be doing limits at infinity, so, and minus infinity. So all these things still work, provided you have Okay, there's certain issues you have to watch out for, right? Because you can't, if a is minus infinity, then, you know, you're going to have trouble with this guy here. So a few obvious things to watch out for, but in general, these limit laws work for one-sided limits and limits at infinity. All right, so let's try a few examples. So a lot of these are kind of straightforward. You just kind of do what you would probably naturally do anyways. Okay. Now I'm going to use limit law number 5, which says that the limit can be applied to the top and the bottom separately because those limits both exist. This is a real number in its own right. This is a real number in its own right. Okay, there's no weirdness there. And also this is non-zero, right? This one on the bottom. Okay, you'll notice that I dropped. Here I wrote limit, x goes to 2. And then in subsequent steps, I just write lim. Okay, that's a nice little shortcut I'll allow you to use. Okay, at the beginning you establish what x is going towards, and then afterwards it's not necessary to say that again. It's kind of a pain to put x goes to 2 here and x goes to 2 here. So I'm a nice guy, I'll let you do that. Okay, so we can do these two limits separately. And the idea is that they're both real numbers, and the one on the bottom is non-zero. Okay. How about this one? X squared plus 9. So this is going to be limit law number 10. Okay, if I have a square root, then I can just do the limit of the inside. And I get square root 18, which is 9 times 2 inside. And then the 9 can come out. Boop, and when it comes out, I square root it. It becomes 2. 3. But square root of 9 is 3. Okay. This one. I cannot use limit law number 5 because the limit of the bottom is 0. So let's write that. Limit x goes to -1 of x cubed plus 1 is 0. So can't use number 5. Limit law number 5. Cannot use that. So here I have to do something more clever. And the clever thing to do here is to factor. Okay, that is on the bottom I have what's called a sum of cubes. Sum of cubes, which is a cubed plus b cubed, is memorized to be a plus b, a squared minus ab plus b squared. So you memorize that, and you make use of it downstairs. X plus 1 is my a plus b. And I get x squared minus x plus 1. Then I get the cancellation I want. And this was 0 over 0. But my cancellation has removed that difficulty. So now I can just plug in -1. So I get 1 over 1 plus 1 plus 1, which is a third. Okay, another example where limit laws will fail you. How about limit x goes to 0 plus of 1 over x minus 1 over x squared. Now, the two separate limits are both infinity. Well, we're going to talk about them shortly. Okay, it's going to equal infinity. It does not exist to me. It's not a real number. So I can't use the limit law. Okay, I cannot. So this is not going to equal just, lim 1 over x minus lim 1 over x squared. Okay. So for your notes, so therefore can't use, which one was this? A difference. It's a difference. This is number 2, I believe. Number 2, let me just double check that. Oop, my way too far. Number 2, it is, yes, number 2. Can't use number 2. So what do I do? Can't use number 2, what do I do? Okay, what I do is I do a common denominator here. So the common denominator will be x squared. So it's going to be, so I multiply this fraction, top and bottom, by x. And I get x minus 1. X is going to 0 plus. And now, my problem is much simpler. Because at the beginning it was very, very strange. This is no longer so strange. This is going to be minus 1. The numerator goes to minus 1. The denominator goes to 0 plus. Okay, so I have a negative number divided by a positive number. So I'm actually going to get minus infinity here. Okay, we'll talk more about these difficult limits elsewhere in the notes, but for now I wanted to emphasize that I cannot use number 2.